Okay.
7 was not even in that range.
6 is close enough.
7 was not.
6, 8.
Number 12 is on a different page.
Honestly, any number would get annoying if you started waving your hands at it saying that 7.
12. The degree is 7. The leading coefficient is negative 5. Because the degree is odd, the leading coefficient is negative. The limit as x approaches negative infinity is infinity, and the limit as x approaches positive infinity is negative infinity. 14. The degree is 5, and the leading coefficient is 7. Because the degree is even and the leading coefficient is negative, the limit as x approaches negative infinity is negative infinity. The limit x approaches positive infinity is negative infinity. Number 18, the degree is 3, the leading coefficient is 1. Because the degree is odd, the leading coefficient is positive. The limit as x approaches negative infinity is negative infinity. And the limit as x approaches infinity is positive infinity. Number 20, the degree is 3 and the leading coefficient is negative 1. Because the degree is odd and the leading coefficient is negative. The limit as x approaches negative infinity is positive infinity. And the limit as x approaches infinity is negative infinity. 22a is a picture that looks like bloop, but we can look at more than that in a minute if we need to. The degree, what? No, it doesn't. It looks like bloop. Okay. The degree is 4, and the leading, we can totally look at it more if we want to. The degree is 4, the leading coefficient is 43.77. Because the degree is even and the leading coefficient is positive, the limit as x approaches negative infinity is infinity, and the limit as x approaches infinity is positive infinity. 24. 6 real zeros and 5 turning points, and they are 0, 6, and 2. 26. 4 real zeros, 3 turning points, and they are 0, 8, and negative 4. 28 has 8 real zeros, 7 turning points, and it has no real zeros. 30 is 5 real zeros and 4 turning points, and they're 0, 5, and negative 3. And we go through what? That's it. Yes? No? No, 32.
Oh, 30? Shouldn't it be negative 5?
Yeah, negative 5. I don't know what I said, but yeah, negative 5. 32, 5 real zeros, 4 turning points, 0, 4/3, and negative 5. What questions do we have on those? 30.
Is 4/3 close to square root of 2?
No. I mean, yes, actually, technically, but like that, it would have to be exactly 4/3.
Okay. I was just making sure I was in the general area, though.
Yeah, I mean, that's, yes. Yes, I mean.
Neither do I.
Because 4/3 would be 1 1/3, and square root of 2 is 1 point, I don't know, something, so.
1 point like 5. The order of 1 point, or square root of 2 is like 1 point high, or 1 point low.
You always think about it as like it's between, like what it's between.
Yeah, 1.4,
So.
1, 4, 2, 1, 3, 5, 6, 2, and then whatever.
When you're trying to guesstimate it. Number 30.
You only did the limit, right? Or did you put the degree and stuff? Is that right? Or did it just say?
I put the degree in, like,
I thought it was
The limit is the describing the end behavior.
Yeah, all I did
That's-
was the limit
that-
because it said end behavior, and I just didn't think
Yeah.
about the degree.
I just said like the degree is odd and the leading coefficient is negative or positive.
I just did my
The part that what it did say that would be saying that is the explain your reasoning part. So the reasoning would be because of the other.
I just used my notes as my reasoning.
Well,
That works.
that doesn't make
Little
sense.
pair functiony thingies.
Yeah, they're like, if it's negative and positive.
It
or
works
it's negative
'cause that's
and
how it
it's
is.
positive.
And then I just
odd.
used my brain and I went limit.
Math is
This
math,
one.
and math will always be math.
It wasn't even math, it was just
Okay,
brain power.
so the instructions here say the possible real zeros and turning points, then determine all of the zeros by factoring. Great. So, what's the degree? How many turning points are possible? Degree 5.
4 possible.
4 possible turning points.
And then we factor it.
Then we factor it. So what should we do?
Take out a 6x and a third.
6x to the third. Okay, when we take out a 6x to the third, out of the first one, what is left, Landon? I wasn't picking on you. They were just like sounding like a cult, so we had to let you join in. Okay, so what is negative 150x cubed when we pull out 6x cubed?
25.
Oh, I thought that, I wrote it down on my paper as 15.
All right, now what do we have?
Now we can just say x and 5.
Squares.
negative
It's subtraction of squares. It is
have
actually.
So there's two ways to look at this, right? We can go ahead and set each factor equal to 0, right? Y'all are saying a bunch of random words. And we set this one equal to 0. And then we can either factor this right now, difference of two squares, easy peasy, or we can add 25 to both sides, square root that, and when we square root both sides, we get plus or minus 5, right? Right? This one we're going to divide by 6 and end up with 0. The cube root of 0 is 0, right? So either any of the ways you get there, you're going to end up with 0 and 5 and negative 5.
Okay, so that actually was an easy problem. I just wrote 150. 150 is 15.
And not 25.
Huh? I put 150 and I wrote it down.
You would get, so yeah, you could still solve it with that. You're going to end up getting some irrational numbers.
Yeah, I just figured I did something wrong.
Yeah, you get it would be 0 and plus or minus the square root of 15, right? Is that what you got? 0 and plus or minus the square root of?
I just stopped.
You just stopped. You're like, I don't know what's happening anymore.
It's over.
I see. Yeah. So if you did it that way, you could still do it. You would pull out an x cubed, right? Not the 6. You would end up with 0, and then the other one would be plus or minus the square root of 15, because you would solve it the same way, right? You would add the 150 and then square root both sides, and so you could still do it that way. It would just be an uglier answer.
I think we should do 32
Would it be
to
a
find
correct
out why
answer?
Reese got a square root of 2. Not
Do we need to do Reese, the 32 Reese, or do you understand what you did?
I did my factoring wrong.
Okay.
When I did the homework,
Any other questions on this chunk?
Trying to call me out like that.
what are we doing? 2, 3 now?
Taking a quiz.
No, we're finishing 2-2.
We're done with 2.
We're not done with 2-2.
We're not done with 2.
I did say that last time. Y'all don't like to listen so good.
No, I don't like listening.
Oh, I do remember it.
This is a known fact about me.
Listening is not fun.
2, 2 continued.
2, 2.
Mm-hmm.
Okay, I'm gonna wax those y'all very hard.
It's just 2.
You know, 2.
Actually, we may be done with 2-2. Yeah, that's fine, actually.
Yay!
Yeah, that's fine.
2, 2.
Because we're going to hit the remainder and factor theorem next. Yeah, that's fine. Okay, so let's remind you how to do long division of polynomials.
Oh, this. Oh.
Oh my gosh, turds.
Malcolm.
How about we kick Malcolm again?
Okay, so we are going to factor this completely, given the existing factor and long division. So we're going to take and factor 6x cubed minus 2x squared minus 16x minus 8, which we are given that it has a factor 2x minus 4. Okay, so if this is a factor of this, then when we divide this by this, we'll get a remainder of 0, right? Okay, so what we're going to do to make this simpler, to make it where we can grab, now this could actually be factored using grouping or something like that, I don't know. Oh, but we're going to use this method. So we're going to start by dividing this into this and seeing what's left after we factor that out, because we know that that's one of the factors. So how do we divide polynomials? Do you remember the steps? We got to have a little porch and a little house.
Oh, like when we do the cardboard box thing.
And then we've got the 2x minus 4 on the porch, right? And then we're going to do this. Now, if one of these terms was missing, what would we have to add? A 0 where that one is, right? There isn't any missing, right? So we've got 6x cubed minus 2x squared minus 16x minus 8. And yes, we can do synthetic division. We're going to remember how to do that in a minute. So what are the next steps?
The next step, so
We gotta multiply it times.
No, you're not to the multiply yet. We got to divide first.
Oh yeah, and then we gotta multiply.
So we're going to divide this first one into this one. So what is 6x cubed divided by 2x?
3x squared.
3x squared. Now we're going to distribute this onto these. If you did it right, then these will match when you line up. So 3x squared times 2x is what?
6x cubed.
6x cubed. Easy peasy. All right, 6x squared times negative 4 is what?
It's 12x.
No, it's not. But it is negative 12x squared.
yes, negative 12x.
What would be the next step?
To add.
Not add. Subtract, which means you got to flip both the signs, right?
Subtraction. Why are we still doing this?
So these first two are going to cancel. Easy peasy. So then negative 2x squared plus 12x squared is what? 10x squared. What would be the next step?
Then we gotta divide.
Then we got to bring this one down.
I keep trying to say more.
And then yes, we would divide 2x into 10x squared, which is what?
5x.
Plus 5x. And then what would we do?
Now we multiply it.
5x times 2x.
10x squared.
10x squared. 5x times negative 4.
Negative 10x.
Definitely not.
20.
Negative 20x.
Wrong number.
And then we subtract, right? Easy peasy. Those cancel.
And that becomes
4x. Bring down the minus 8. 2x into 4x is what? 2.
Okay.
Distribute. 2 times 2x is 4x. 2 times negative 4 is negative 8. And if we did everything right on this kind of problem, we end up with a remainder of 0, which is great. So now we can rewrite this as 3x squared plus 5x plus 2 times 2x minus 4, right? Let me slow down and have a second.
Now we're gonna have to do
The only reason you're where you are is because you're not writing a dang thing down.
Right.
What? It's a note.
I was writing down stuff.
I was writing your stuff. I'm
I
writing.
forgot, okay?
Right? Okay.
How do you forget to write down notes?
Because I was engaged.
You were engaged.
Now, in order to finish factoring this, what are we going to do?
We can split out the.
Yeah.
Yeah, we can
Normal trinomial factoring style. We got 2 sets of parentheses, right?
2x in one and then x in another.
2x times x is not 3x squared.
Yeah, you're right.
How about 3x and x?
Yeah. I was doing addition instead of.
And then what?
Put 2 and then not
Two on the closest parentheses and then one on the other one.
Yes. I don't know what you mean by closest, but this.
The first
If we did it the other way around, we could still get the middle one, but the sign on the end would break, right? Because 6 minus 1 would give us a negative 2 over there, right?
Oh, we gotta factor even more.
Oh, that's as factor as it gets. What do you mean? What are you asking?
Yeah, what are we doing right now?
We're finished.
We're having a fun time.
I was just saying, like on this particular problem, you might make, y'all probably wouldn't unless you're going too fast and not thinking about what you're doing. If you factored in 5x and x, and then you did 1 and 2, and then you did minus and plus, then you would get the 5x. But the sign breaks at the end. So this is the answer, not this. That's what I was saying.
Oh, I would have figured that out eventually.
Yeah. That would be, in pre-cal, that's less likely that you'll make that mistake, but definitely still possible if you're kind of blowing and going too fast. All right? That's easy peasy. Easy peasy. Okay.
both of y'all.
Let's do another reminder. The instructions on this one just say divide. Okay?
Instructions on the last.
Factor completely using the given factor and division. Okay? Okay. Divide using long division. And we going to do 8x cubed minus 18x squared
I'm waiting till he finishes so I can see all.
plus 21x. I am saying it out loud so you don't have to do that.
It's harder, okay?
Minus 20. You are using pencil, right? We're dividing this by 2x minus 3. So same steps, right?
Build a cardboard box.
We're going to put the 2x minus 3 on the porch.
What about cardboard box y'all talking about?
8x cubed minus 18x squared plus 21. X minus 20. Going to divide, right? And get 4x squared. Then we distribute 4x squared times 2x. 8x cubed. 4x squared times negative 3 is negative 12x squared. Slow down, Sean. Okay, good.
I subtract that.
We're going to subtract. Change both the signs. Minus, plus. That cancels.
Negative 6x squared.
Negative 6x squared. Bring it down. Plus 21x. Divide. 2x into negative 6x squared is negative 3x, right?
Oh, yes.
Distribute. Negative 3x times 2x is negative 6x squared. Negative 3x times negative 3 is plus 9x. We subtract that, which means changing both the signs, right? Yep. That cancels. 21x minus 9x is positive 12x. 2x into 12x is 6. Just 6, right? Because the x is canceled.
X's kill each other too.
And then 6 times 2x is 12x. Great. 6 times negative 3 is negative 9. If I would have brought down the negative 2, I would have had something to combine it with.
18.
Yeah, that's right.
And shouldn't that be a 20 at the back, not a 2?
Yep. Negative 18. I don't know, I'm copying things down wrong. That's what I'm doing. I don't know what you're doing.
Now we flip the signs.
That's
and
what
We
I
subtract.
So kill the front thing,
And 2.
and then you get 2.
Negative 2. Okay, so this problem, at the end of this problem, we didn't end up with a remainder of 0. So what do we need to do? How do we write the remainder?
We add that over 2x squared, 2x plus minus 3.
So the final answer is 4x squared minus 3x plus 6 minus 2 over 2x minus 3. X cannot equal 3 halves.
Yes, 3 halves. Because you add 3 and then divide by 2.
Because it can't be
Oh, yeah.
2x minus 3 cannot be 0. Add 3 to both sides. 2x cannot be 3. Divide by 2. X cannot be 3 halves. Right?
Then London is getting so.
Easy peasy. All right. Let's remember how to do synthetic division.
Is this the cardboard box one?
No.
What is a cardboard box?
Brady, don't remember
Why
last
are you
year?
so excited about cardboard
Is this
box?
cardboard box one?
Last year we talked about cardboard boxes for like half of one of the classes.
No, you did.
I did.
Which is like the same as now, right?
Nathan,
What is the cardboard box?
I think you were sitting next to me and then Nathan.
All right. We are going to, using synthetic division, divide 4x cubed
He was always so annoyed at me doing that.
plus 3x squared minus x plus 8 by x minus 3.
Do we have to factor?
We have to divide this using synthetic division. So for synthetic division, we're going to do a little box.
The cardboard box.
Inside the little box on this problem is going to be positive 3. Where did I get that from?
The opposite of 3. So x equals 3.
The opposite of this, right? And then over here, we're going to have 4 and 3 and negative 1 and 8. There's the coefficients, right? Then we're going to have a line. What is step 1 going to be now that we've got it all set up? No, it's not multiply 3 times 4 yet.
Subtract 3 from
No.
Divide 4 by
Do we have
3.
Learning math as a non-English talker. Well, welcome. I'm sorry I don't really speak any other languages very well. I know a tiny bit of Spanish, but that's about the best we're going to do. So hopefully this is more useful than not. Okay, so we got to bring down that 4 first. That's the first thing that happens. The 4 just comes straight down. Then we do multiply 3 times 4. 3 times 4, which is 12.
And then we subtract.
Then we add.
We add.
We take care of the subtraction by change. That's why we change the sign.
Oh, yay, that's
15.
15. 3 times 15 is 45. And then negative 1 plus 45 is what? 44. What's 3 times 44?
132. Gosh, damn, are you serious?
132.
Did you do it by multiplying 40 times 3 and then 4 times 3?
8 plus 132 is what? 140. Okay. So we just need to write this back in polynomial form. So it is going to be 4x squared plus 15x plus 44 plus 140 over x minus 3. Okay, so what puzzle pieces are in there? What cobwebs are we dusting? What all happened? How did I get that?
I don't know, but I like the way we're doing this, and let's not do the other way ever.
Okay. Well, there are some circumstances where you have to do it the other way. Namely, if you're dividing by something that it doesn't have a degree of 1, then you have to use long division. But usually those are short, so, whatever. So, this degree is 1 less than this degree.
Yeah.
And then we just shove the coefficients in. That's the remainder.
What do we do?
X cannot equal 3, right?
Wait, could we just do this a bunch of times? If there was more degrees? Yeah, that made no sense.
Yeah, you're going to do that in order to find factors here pretty soon. You're going to fill up pages with synthetic division. It's going to be great fun. We did it in Algebra 2. You're going to do it again. There are ways this year to use your graphing calculator to figure out what you're going to do, so you have to do it less times. No, it's not. It's just like a lot.
What do we do whenever x has a coefficient?
It feels like everything in
That's going to be the next example.
Yeah. I can use this on
But it
other
feels like we
times
just
too.
have graphing calculators and just keep
Okay. So we're going to do synthetic division where A on our, I never can remember, which one is the divisor? The dividend? I don't know. I don't teach elementary math.
Actually cares.
I don't know. The one we're dividing by doesn't have an A that's 1. All right, let's do that one. Let's do synthetic division. 6x to the 4th plus 11x cubed minus 15x squared minus 12x plus 7 by
Do you see that first number and then the very last number?
3x plus 1.
6 and 7.
Do you have permission to hurt them?
What are you saying?
Gosh, this is 6 and a 7.
Why is it making that a notification? I don't understand. Go away. Okay, so we have a problem because you can't do synthetic division yet. We have to do something else first.
The 3x.
So in the house, in the box, is going to be negative 1/3. And then here, I'm going to write it out, and then we're going to puzzle through what's happening. This one is going to be a 2. And then this one is going to be 11/3.
That's easier.
This one's going to be negative 5. And this one's going to be negative 4. And this one is going to be 7/3. What did I do? How did I get that? I divided everything by 3. That's exactly right. Now we do our normal synthetic division, just like we've always done. We've got fractions. But the fractions typically are not that big a deal on these. Right. Bring down the 2. 2 times negative 1/3 is negative 2/3, right? 11/3 minus 2/3 is 9/3, which is 3.
And then that's
Negative 1/3 times 3 is, yes, 1. Happy days are here again. Negative 5 plus 1 is negative 4.
And then negative 4/3.
No, that's a lie.
Or 4/3.
Wait.
Positive 4/3.
How did we get the one to be positive?
How do we get what 1 to be positive?
The one that we, below the negative 5. How did
Oh,
we
I
get
don't
that to
know.
be positive?
That's what
Because I made a mistake.
So we have negative 6.
Negative 6. Positive 2.
Oh yeah, that's nice.
Negative 2, right?
That's still fine.
And then positive 2/3. And then 9/3, which is 3.
Okay, this is pretty looking.
This is not so bad, right? So then we've got the answer 2x cubed, 1 less than that one, plus 3x squared minus 6x minus 2 plus 3 over 3x plus 1. X cannot be negative 1/3.
That's a pretty looking answer.
Whoa.
Never mind.
Whoa.
We didn't get the same answer as the book, but I think theirs might be a mistake. What did we get? 2x, 3x, minus 6x. That's
No, let's do it.
yeah. Theirs is a mistake. I should fix that in my book.
They messed up.
I like it whenever they
Yeah, they got 9 as the remainder, and I see what happened, but
9/3 became 9.
yeah, just which would be easy to happen.
You sure you hit the fraction button?
Well, or just forget to you just like, oh, 9, and then just moving along, right? Either way. Okay.
Do we not factor again?
it just does it. Or
No, not on this problem. This is just divide. All right, your homework.
AI calculator,
Honestly, that'd be a great calculator.
right?
There'd be no need for people. Because the calculator would just do it.
Oh yeah, it's there. Okay, good.
That's
Yeah,
good.
we are not, in fact, done with this lesson.
Oh.
We're gonna do synthetic. We need to do synthetic substitution and the remainder theorem, which we've learned in algebra 2, but we're gonna review it. But we are. Oh no, just kidding. It's only almost noon. We got like 30 minutes.
Oh, snap.
Great. We're gonna finish this whole lesson. Good.
Yay.
Might even get into the next one. Who knows? That sounds wonderful. I love it.
Say yay, Malcolm.
Okay. So if you want to see the exact text, you want to copy it in your notes, you can. The remainder theorem, the exact text is on page 112. Basically, what it says is that that if a polynomial is divided by x minus c, then x minus c. What are we saying?
What? What did he say?
Oh yeah. It's for synthetic substitute. I'm sorry. I was thinking of a totally different theorem, which is the factor theorem. I was trying to tell you the factor theorem. The remainder theorem says that if you divide something by f of negative c, then the remainder is the answer to f of c. Let me show you with an example. Yeah?
Yeah, I was just,
Okay.
my brain just hurt there.
That's okay.
It done did hurt.
It done didn't go like me.
Where's my marker?
Bro, you sound like that hillbilly from The Simpsons. What's his face? Clevis. You sound like Clevis.
Okay.
Exactly.
For the polynomial,
Yeah. He has like 70 kids or something.
t of x equals x cubed minus 12x squared plus 48x plus 74. We are going to use synthetic substitution to find t of 13. Okay, so
I think so. I don't remember. It was something in this lesson-ish.
okay, so we could shove that in there and do it that way, but we're going to use synthetic substitution. So synthetic substitution uses the remainder theorem to say that we can divide this by negative this, and the remainder is the answer. So that's what we're going to do.
Does the remainder go in the
So we bring down a 1, negative 13,
I should probably write this down.
negative 25, times negative 13 is positive something. What is it?
Wait, okay, that was aggressive.
He's trying to be the fastest.
Yeet.
Now I'm just trying to be slow.
3 times 4 is 100.
13 times 25. You have a calculator 2 inches from your elbow.
325.
That's what I was getting to.
Negative
If I have 2 more seconds.
And 325 plus 48 is what?
Some number.
That's
Times 48 number.
Not times
83.
373.
What are we getting at?
I saw 5.
And 373 times negative 13 is what?
373. Landon's got that.
Negative 4,849.
I should check that.
4,775.
What?
That's not how that works.
Negative 4,849.
No, for the next one. For
Oh,
The next
74.
one. Oh.
It's going to be negative something.
I know, negative 4,775.
Oh.
That's what I said.
Yeah.
Nobody understood what you were saying.
All right. So let's see whether this matches or not using a normal substitution.
What was that?
What's 13 cubed?
13 cubed. Where's
2,197. Gosh dang
Don't be
it.
a soda.
You didn't even
What's 13 squared?
No, I put 3 first.
169.
Oh yeah. I don't know what I was thinking.
169. How do you have no money in your wallet?
What's negative 12 times 169?
Negative 2,028.
What?
Negative 2,000 what?
28.
What is this? Somebody want to multiply 48 times 13?
What's 48 times 13?
What? 48 times 13!
624.
624.
624.
I'm done with that noise.
Yeah. Yeah.
Where did we go wrong? Because we're not getting the same answer.
Well, you subtracted something. Hold on. Guys, if that wasn't negative, the second number, then that would work, would it not?
Oh. Because I'm dumb.
Is it supposed to be plus 12x squared?
No, it's not supposed to be plus 12x squared. Oh my gosh. This is what I get for trying to explain things out loud instead of just writing them down. For x minus c, if we divide it by x minus c, the remainder will be f of c. What do we notice?
Oh, that's negative. C is 40.
C is just that, so this should be 13, not negative 13.
That causes issues.
Okay, let's try again.
I should have said something about that. I saw it and I was like, oh, it must have been how it's supposed to be or whatever.
Yeah.
So when you're, in a minute, when we do the factor theorem, This is where it gets you have to keep things straight in your brain. In a minute when we do the factor theorem, you do need to switch the sign because you're trying to factor it. But when you're using synthetic substitution, this is the only case where you do not switch the sign when you're using synthetic division and you're doing the thing. It's the only one. You don't switch the sign in synthetic division. That's what you need to remember. That's the key takeaway, right? So 13 times 49 is what? 800 and some odd?
What's 13 times 49?
Why'd you do 13 times 1 is
600 and
Oh.
37.
61.
That changes everything.
What's 13 times 61?
793.
793.
793. 74.
867.
So this should be, assuming we don't make any mistakes over here, 867. So when we do 2,197 minus 2,028 plus 624 plus 74, theoretically we get 867. Why don't you punch it in and see?
I do.
You get 867.
Alright, and which one is this one?
I do as well.
Synthetic substitution. So when the instructions say find this thing using synthetic substitution, you just plug it in. And that's the only time you don't change the sign. Other than that, you change the sign every time.
Synthetic division, you change the sign. Synthetic substitution, you don't.
I'm going to go back and
Well, so synthetic division is this part. Synthetic division is just the method, right? But when you're trying to do a factor, you change the sign.
Okay.
Yeah. Synthetic division is just this method. And if it says divide this using synthetic division, you would change the sign of the thing. Synthetic substitution, you'll just be given a number, right? So like if you look at the problems that you're going to have for homework, on the synthetic substitution ones, the 31 through 37, it just says the number is this. You shove the number. What is funny? Every time I look back at your face, you're like chuckling about something stupid.
He's looking at the...
Okay.
He's looking at the final answer.
He's looking at the final answer.
Okay.
I shouldn't be laughing at it.
You really should not. It's not that funny.
Okay.
It's kind of funny, but it's not that funny.
It's not
It's
that
funny annoying, man.
Well, yes, that's
Okay.
what's funny about it. And
So the factor theorem says that x minus c is a factor of f of x if and only if when you divide f of x by x minus c, you get a remainder of 0. Okay? So you might have a problem that would ask you to determine whether this particular thing is or is not a factor of the function, something like this. So we want to determine whether x plus 5 is a factor of 3x cubed minus x squared minus 22x plus 24. So we divide that. We can divide it using synthetic. You can divide it using long division if you felt like it, right? But we can use synthetic substitution, right? Or synthetic division, right? To see whether it works. So here we go. 3, negative 1, negative 22, 24, right? Then we bring down the 3.
Negative 15.
question.
Negative 15. What is your question?
Could, if you were given the x plus c, you could.
We are given the x plus c.
Well, yeah, I'm saying if you weren't given it, could you find it?
There are ways to figure out what they are. You just test it and see whether it works, which will be like the next lesson, I think. So yeah, that's definitely.
Negative 16.
Negative 16 times negative 5 is positive
80.
80.
I don't know why I had to do that negative. It makes no sense.
Negative 22 plus 80 is positive
58.
58.
I did that in my head.
Negative 5 times 58 is what?
Negative 290.
Yep.
What is it? Yes and no. Binomials given factors. Use the binomials their factors to write a factored form. Oh, because it gives 2. It wants us to check this one and check this one. I was so confused because this is not going to be a factor. This is not going to work. I said, what is happening? Yeah, so we could keep on going, but obviously negative here is that, and we're not going to get, it's not going to be 0. Bad. This is not a factor. Sad day, right? Often when you're testing these, you can figure it out sooner rather than later. So we're also going to check positive 2 to see if positive 2 is. So 3, negative 1, negative 22, 24. And so bring down the 3. 3 times 2 is 6. Negative 1 plus 6 is 5. 2 times 5 is 10. Negative 12. And Bob's your uncle. This one is a factor. And so the further instructions say if it is a factor, use it to write the factored form of that. So now we have x minus 2 times 3x squared plus 5x minus 12, right? Yep, we got to go from here. Right? And then we can just factor this like normal.
How much factoring do we have to do?
Lots.
So much.
So 3x and x, and then what else are we going to do?
And then we got
We could do, no, that wouldn't work.
2 to 6.
We could do 12 and no, that wouldn't work.
Hold on. 2 to 6.
4 and 3.
4 and 3. Let's try it. See what happens.
Let's try it.
4 times 1 is 4. 3 times 3 is 9. Minus plus. Minus times a plus is a minus. He works. Right?
Let's go. I got it first.
You guessed first. Yes. Yes, you did.
I know.
Yes, you did.
It was sort of an educated
'Kay.
guess. I kind of just did it.
Let's do it. Let's do another one of these.
These aren't bad.
Because
Because there's no graphing.
there's no graphing.
Yeah, I do agree with him on this topic. That one does save paper quite well.
What do you mean? Oh, that's a lot of.
Bro
paper.
uses the back of the page. You know,
I use the
I
back
can't
of
do
the
it.
page.
I cannot use the back of the page.
But I don't
Okay,
graph.
so we're going to see whether
I don't want to do
I
that.
take it out.
x minus 6
Bro, why
is
is
a,
this guy here?
or, because he takes science classes, x minus 3 are factors of 4f of x equals 4x cubed minus 34x squared plus 54x plus 36. Right?
Now we gotta test them both.
We got to test them both. So we're going to put 6 in the box. 4 minus 34, positive 54, 36. Bring down the 4. 6 goes into 4. No. Y'all know what I meant. Y'all know what I'm trying to say.
12.
Times 20 times 4 is 24. Negative 34. 6 times 4 is
Negative 10. Landon, why are you the one doing it?
I don't know. It just happened after you.
negative 60. Negative 6.
Negative 36.
Negative 36. He works.
Wait, they cancel it, then we get a 0 and
Now
we're
we
all
don't have
happy.
to
Great.
do the other one.
Now, here's the cool thing, right? Since we found one, we can synthetic division we can do this and divide into this one instead of the big one. Since we found one, we can use the depreciated one, right? So we can go 3, and then does that go into 4, negative 10, negative 6.
Ooh, I kind of like this.
And then we get 4, and then we get 12.
4, 12, 2, 6. It also works. So yes and yes. So now at this point we have x minus 6 times x minus 3 times 4x plus 2.
Hey, we don't even have to factor that one.
We're not quite done, kid.
Oh.
That's not as simple as it gets. What's one more thing we can do?
We can no,
No, we can't. That's not true at all.
Set it to 0 or something? I don't know.
We could pull a little something out of something.
No, we can't.
No, we can't.
Because the 3.
3.
2 times yeah. Oh, we only have to pull it out of that one?
Yeah.
You can just yank it out of one of the random ones.
Yeah. I mean, that's like factoring it out of here, right?
Okay.
And then associative property says I can go.
Yeah.
Association.
Actually, not associative, commutative. Sorry.
Commutative, that's
I don't even remember.
Easy peasy, lemon squeezy. Now, homework. Number 1.
Let me get my page.
Whoa.
Wait, ready?
Number 1.
Yeah, you might have some more.
What?
We're doing an odd number?
No.
What?
You might have 2 homework sets.
Please no. Please no.
You're gonna be fine.
We did nothing wrong. Or at least me and Reese didn't.
Numbers.
Why did I just draw my hashtags like an X?
It's a pound.
It's pound.
12 through
I always call it the number sign.
That's what I usually call it, but it looked like a hashtag today.
44 even.
12 through 44.
Okay.
This is what makes me not want to do my homework.
Lesson 2-4.
Oh,
wait,
wow.
What did we switch to 2-4?
Yeah,
Well,
then once
we
start
finished
doing
2-3.
stuff-
And so now we're on 2-4.
Wait,
But
we're
we
doing
never-
more notes?
Yes.
Oh, we're doing more notes. We're doing more notes.
What?
Okay.
Wait, what time is it?
It is 12:15. You have plenty of time. Nobody asked.
Last time. Oh, please stop complaining so much.
It is Thursday, y'all. You have plenty of time till Tuesday to do more stuff.
No, I actually don't. My mom forces me to get it done by Friday.
So,
Great. Good for your mom. That's good. Like legit. Not even a joke. Not even your mom joke. Just good job, mom.
your mom is good.
That's the end of the story. Okay. Let's dust off some more cobwebs. Rational zeros theorem. And I'm going to teach this practically instead of like trying to say all the words. Okay. So, what does rational mean?
It's not irrational.
Malcolm, can I back in now?
It's irrational.
What does rational mean? What is a rational number?
You can like
You
have
can
it,
divide
it's
it.
like a real number.
It can be written as a fraction.
Okay.
Okay? So not the square root of 3, not pi, not e, not I, right? Anything that can be written as a fraction. So, as we know and as we've seen, functions can have rational zeros. That is one possibility. We can do a little bit of looky-loos to see whether or not it has, or how many rational zeros it can have. Actually, real zeros. Sorry. I'm doing the second half first. Okay, if you want to know how many or what possible rational zeros there are, you have to factor some stuff. So if you have a polynomial in the form f of x equals a sub n
What? Whoa, what was that word? Sub n. Oh, okay.
x to the n
That's fine.
I heard like
plus a sub n minus 1, x to the n minus 1, etc., down to plus a sub 1 x plus a sub 0. We can get a list of all possible rational zeros. No, not calculator.
that was exciting. Calculator needs less work.
And this only works if a sub 0 is not 0. If a sub 0 is something else,
What is sub-zero?
the last term, the one that doesn't have an x on it,
Below the freezing.
right? So the constant, right? So if that is true, then you have to first factor out an x or whatever x is and make it not be 0, right? Because if it's not, what am I writing? That's not right. Oh yeah, no, that's right. Yeah, yeah. So if it is this has got to be a number. If this is not a number, factor out an x or however many x's you can factor out, and then do it with that one. Okay. All of the p's over all of the q's. Now, what is p and what is q?
Parentheses.
Okay. P is all factors of a naught.
I've already accepted. I just have to watch 10 YouTube videos about this.
Okay, lock in.
No, stop. Stop.
Write stuff down.
Stop.
So
Write the notes. Lock in.
no.
Don't give up your brain. We're not out of class yet. This is not. We're not out of class yet. Write down this, and then we get an example, and we concrete it. Right? That's how this happens. Q is all factors of a sub n. Now, a naught is the constant, right? The one that doesn't have an x. So the last term. A sub n, what is that called? He's got a name. We know what that is. That very beginning term, what is he? That again.
I'm writing stuff.
Please repeat what you had just stated.
A sub n has a name. That very first term is what, his number on front is what is he called?
Degree?
No, that's the power. That's n. What's
We're talking
leading coefficient?
Let's go.
It's not that exciting though.
No, I got it right. That's exciting.
Okay. So let's do an example.
All right.
So we are going to list all possible rational zeros of
Wait, what are rational zeros?
zeros that can be written as a fraction. Okay. All possible rational zeros of g of x equals 2x cubed minus 4x squared plus 18x minus 36. So, what is the leading coefficient? 2. What are the factors of 2? 2 and 1. What is the constant term? Negative 36. We don't really care about the signs because it's going to be plus or minus on everything. Because it could be positive 36 times negative 1, or or negative 2 times negative 1, all the things. So it's always plus or minus. Okay? So factors of 36: 1, 2, 3, 4, 6, 9, 12, and 36.
Wait, 18. We're missing 18.
We are missing 18. So to list all possible rational factors, it is all of these over all of these. So 1 divided by 1 is 1. So plus or minus 1. 1 divided by 2 is 1/2. So plus or minus 1/2. 2 divided by 1 is 2. 2 divided by 2 is 1. We've already got that. We don't got to list it again. 3 divided by 1 is 3. 3 divided by 2 is 3/2, plus or minus 3/2. 4 divided by 1 is 4, plus or minus 4. 4 divided by 2 is 2. We've got 2 already. 6 divided by 1 is 6. 6 divided by 2 is 3. We've got that already. 9 divided by 1 is 9. 9 divided by 2 is 9/2. 12 divided by 1 is 12. 12 divided by 2 is 6. We've already got that. 18 divided by 1 is 18. 18 divided by 2 is 9. We've already got that. 36 divided by 1 is 36. I don't know what I'm writing. And 36 divided by 2 is 18. Yeah, we already have it. So that is all of the possible rational zeros. Any one, some, all, or none of those could be rational zeros. So the rest of the instructions for this problem say, list all of them, list all the possible ones, then determine which, if any, are zeros. So we would have to start now if we were last year in no, not pre-algebra, algebra 2. If we were last year in algebra 2, we just got to start shoving ones in, synthetically dividing it, and hope for the best. Now, you have a tool to narrow down what we're doing. If you go ahead and graph it, you can see where about they are, and you can pick based on graphing it. So if you graph it on the graphing calculator, you can be like, okay, it's probably this, and then we're going to try that one. So graph the thing. You can even technically use the table to be like, yeah, it's definitely this, and then just show your work how you algebraically did the thing, and then you're good to go.
Okay, not many. Alright, we want -1.
Well, it's gonna have up to 3, right?
-1 is not. +1 is not. 1/2 is not. And -1/2 is not. And 2 is, but -2 is.
Okay, so let's try 2. Let's go ahead and do 2, and then we may just be able to factor, and we're going good, right? So shove 2 in there. So if we're going to test 2, do we need to do -2 or +2 in the box?
Positive 2. Wait, which one are we doing here?
We're doing what do you want to test?
Are we factoring or dividing?
We are factoring.
So then we need +2 in the box.
Okay. So we bring down the 2. 2 times 2 is 4. That's 0. That's a 0. That's 18. 2 times 18 is 36.
0.
So 2 is, in fact, a factor. So now we can turn this into x minus 2 times 2x squared plus 18. Now what?
Why do we get negative x minus 2?
Why do we get what now?
Why do we get x minus 2?
Because if 2 is a factor, 2 is an answer, then it's...
Okay. 2 is
Yeah.
2 equals x. So
2 is
-2x. So x minus c and 2 is c.
3 is not, -3 is not, 3 halves isn't, and neither is -3 halves. 4 isn't, -4 isn't, 6 isn't, -6, 5 isn't, 9 isn't, -9 halves is about 4 1/2. That isn't, and 4 there, and 12.
It doesn't even want those. But which problem were we doing? We were doing this one.
18 is definitely not.
36 is not.
18 is 88,000 something.
Look, I don't know why y'all are wasting your time, Rose. Just look at the thing.
It's easier for me to scroll through the table than to check.
No, it's not. No, it's not. I found all of the zeros, and not even just the rational ones. I found them all. This is what we discovered, right?
Yeah.
I factored out a 2 to get to this line, right? Factored 2 out of here. If we set each factor equal to 0, actually 0 isn't 1, right? That's not true. That would be an x. So 0 equals 2 times x minus 2 2 times x squared plus 9. Set each factor equal to 0. 2 doesn't equal 0. That's not true. Or divide everything by 2. X minus 2 equals 0. So x equals 2. Done. X minus 2 is not big. That's great. And then x squared plus 9 equals 0. We subtract 9 from both sides. X squared equals negative 9. Take the square root of both sides. We end up with x equals plus or minus 3i.
What do we do with the first two?
What first two?
The one that's outside, yeah.
Divide everything by 2. 0 divided by 2 is 0.
Okay.
So it just cancels.
Okay.
If it was an x, then you would say x equals 0.
Hold on. That's pretty nice.
Okay.
Hold up.
This lesson we will split into a couple. Where
Oh, wait, you got this. I was wondering where you got the 3i from.
It came from the others, the negative 9 squared.
Yes, 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 yes. You got this. It's going to be okay. Homework number 2 is on page 127. Numbers 2 through 8 evens. 8. It's like, oh no.
I'm like, yeah, I'm not doing the homework.
Oh no.
Especially if this type of problem. Yeah. If it was like 2 through 80 of 1 plus 1, maybe. I'd think about it.
Well, that would only be 40 math problems. I mean, that would be a not unusual homework assignment back in the day. I mean, that's
Back in the day, it's back.
that's honestly not
Back in the
Like
day, the math problem
that crazy.
didn't take 4 years.
no, like that would have been a normal pre-cal assignment. Like that wouldn't have been like out of 50 problems was not unusual at all.